All right, another important topic that you might want to look at before you start graphing are transformations. So how do graphs change based on the way their equation changes? So with all problems, we typically start with what's called a parent graph or in a parent equation. All right, for our purposes, we're going to work with the absolute value graphs. That was the first one we learned. And all of these transformations apply to both types of graphs that we learned this year. So there's a square root graph, and there are also x squared graphs that these transformations can be applied to. So essentially, what transformations are is changes to the equation that also change the graph. So let's look at this first one here. So looking at absolute value of x plus 2. Well, you got absolute value of x. Add 2 outside. Hopefully you kind of remember, but that shifts the graph up 2. Okay, so we don't necessarily need to make a table every time we do something. We can just look at it and say plus 2 outside will shift the graph up 2 units. So it would look like that. All right. In contrast, if I subtract 2 outside, it would take all the y values or all the outputs and would shift them down 2. So you can see that how the graph's equation changes the way the graph looks a little bit on the grid. So that's if you add or subtract something outside. Well, what if you add or subtract something inside? So in this particular case, this green graph over here, you got y equals absolute value of x minus 4 inside. Well, inside shifts the graph left and right. And in inside, it's kind of counter to what you think. You would think minus 4 would go left 4, but in fact, minus 4 actually goes right 4, and that's the trick. So inside does the opposite of what you think, and outside does exactly what you think. So inside would shift the parent function, which is normally right here, shift it right 4 units. So you see that y equals absolute value of x minus 4 inside, shifts it right 4, whereas this one would shift left 4. So you can kind of see the differences, and they're kind of overlapping there, but you can rewind and watch this again. But how adding and subtracting things inside and outside changes the way the parent graph looks. And once again, all of these transformations also apply to the other two graphs that we learned. All right, so the absolute value graph is the same. The transformations are the same as the square root graph or the x squared graph. All right, so let's talk about other things that you can do to the parent function. So once again, the parent graph, absolute value of x. If I put a 2 in front, the idea, it doesn't shift it, but rather it stretches it. So instead of having the graph go, let me remove the parent graph. Instead of having the graph go 1 over 1, that 2 in front changes the slope. So now the points go up 2 over 1. So you can kind of see how that stretches. That 2 in front makes the graph taller. And the same goes for if I put a 3 in front. So if I take this graph and I think about what a 3 in front would do, that would make the graph stretch even taller. So instead of going up 2 over 1 like the 2 absolute value of x, the sides will go up 3 over 1. So once again, changing the number in front changes the way the graph looks stretched. It stretches it. So if I pull the parent graph here, you can see the differences between y equals 2 absolute value of x, y equals 3 absolute value of x, and then just the normal parent graph. And in contrast, if I take this one and put a negative in front, well, what that does, it no longer faces upward. Instead, it flips upside down and looks like this. So x, absolute value of x, negative in front, flips the graph over the x-axis. So these are just some things to remember as you approach the graphs. Transforming a graph, putting numbers in front, stretch it or shrink it, putting a negative in front flips it, shifting it left, right, up, and down is when you add or subtract numbers outside. So hopefully this helps you as you approach graphing.